So today we're going to talk about space requirements. How much space do you need for your HVAC equipment? So typically, mechanical and electrical space requirements are between 6 and 9% of the gross building area, and they can be as low as 4%. So when you design HVAC, you need to consider equipment rooms that are centrally located. And by centrally located, I mean we're trying to minimize the length of the duct, the pipe, and the conduit runs and sizes. So if we have a building, so most equipment rooms should be centrally located to minimize long duct, pipe, and conduit runs and sizes. And by that I mean if we have a building, for example, so if we consider this building has 3 floors, and excuse the drawing, if we put our HVAC room here, or we could put our HVAC room here, or we could put our HVAC room here, if we put it up on the 3rd floor in the corner, we need to run some ducts all the way across and all the way down and all the way down. Whereas if we put the HVAC room here in the middle of the building, we don't have to run our ducts very far. It's much easier. Every duct is shorter. And the thing is that air starts to cool as it travels. So sending air a long distance is very inefficient. So a long duct is inefficient, and as a result, to get the same effect, we have to make our duct wider. That's something we'll discuss much later, but the point is we want to put our room as central as possible. We want to also simplify the shaft layouts, and we want to be able to centralize our maintenance and operations. So it should be easy for maintenance to access all the equipment that could break down and fix it. So consider a ceiling height for your room from 10 to 18 feet, and that depends on equipment size. And also consider future equipment. Even if the equipment that you're installing now doesn't need that much of a ceiling height, 5 or 10 or 20 years from now, things might change. So having the extra space can be helpful. Of course, there's a trade-off, especially in a dense building. If you're in downtown Manhattan, then the owner of the building wants to be able to lease every square inch he can find. So maybe you won't get as much space as you want. So here's an example of an equipment room. This one is carrying chilled water in the pipe in this direction. We also need to have generators, and the generator should be as close to the emergency electrical load and sources of combustion, cooling air, and fuel. The generator needs to be as close as possible to what it's powering and also to its fuel supply. Maybe that's not always practical because fuel gets replenished. It may come in through a truck, so the generator might have to be outside. So you might consider a central location for your generator. You also need to be able to ventilate exhaust gases outdoors, and consider how noisy your generator is. You, you don't want it to be too close to the occupants. Also consider equipment size and weight, installation, maintenance, and replacement, applicable regulations regarding combustion air and ventilation air, and noise and vibration transmission. If you're installing a cooling tower, it should be at least 100 feet away from the building. And that's for several reasons. First of all, it reduces noise. Second, it keeps the discharge air and moisture from carrying over into the building and discoloring the building. Your building will turn orange if the cooling tower is too close. You also want to keep discharge air from contaminating the outdoor air. Otherwise, what you end up with is you have a building and you have an air intake and you have a cooling tower, and the dirty air just flows back into the building, and that doesn't do you any good. So here's an example of a cooling tower. Now, in large buildings, we have 3 floors or 10 floors or 40 floors. We can put our mechanical floor on one of those floors. So some office buildings, for example, say a 4th floor, this floor doesn't exist. And this floor has a secret elevator, and the only thing on this floor is HVAC equipment. And so we don't rent this floor out. And this connects to all the other floors via shaft. And it costs us a lot more electricity-wise and structure-wise because we've taken up one whole floor of the building for our equipment, but it's a lot cheaper as far as piping, pumps, energy, and chimney requirements. So if you're using gas, you must follow the applicable regulations in your jurisdiction. Gas fuel is more desirable because you don't have to store it. What that means is natural gas comes in through a pipeline. Most big cities have a natural gas infrastructure. So since you're not storing the gas, you don't need to have a big tank. Whereas if you have an oil tank that's sitting outside, you have to burn oil and somebody has to come by and fill up the tank every week or how often you fill it up. And there's always a risk that the tank will leak. So you have to consider if the tank leaks, how much will it cost to clean up? And even if the tank doesn't leak, how much will it cost to monitor and detect the leaks? So what's also popular, and we'll look at this later, are energy recovery systems. They can reduce the size of your heating or refrigeration plant. And the way they work is you're producing heat energy based on whatever capacity to your building, and all of this heat is leaving to the environment. So you can put in a system that recaptures the heat, some of it, and either puts it back into the building or sends it back to your plant, and your plant will capture the heat and send it back, and that cuts costs. Fan rooms house your HVAC equipment, and they could include other equipment So it's important to consider maintenance when choosing a location for your fan room. And also consider security. What is your air intake height? So if we look at this photo, for example, we have an air intake here. If fresh air enters the building through this vent, through this intake, I mean, obviously they put in a sign here. It says to turn off your engine because dirty air can come in through this intake. Or somebody could play a prank on you and introduce something toxic into the air. Or if this intake was closer to the ground and it snowed, the snow could cover up the intake and the building wouldn't get any fresh air. So most systems that are decentralized have a horizontal distribution, and by that I mean horizontal. Uh, you have a source, and the vents go this way, they don't go up and down. So if you're sending out water instead of air, you don't really need much because you just have a tiny water pipe. So the water pipe might be in the floor or it might be in the ceiling, and you only need a few inches of space. If you're distributing air, then you need possibly a foot, possibly 2 feet. It's much more space required. If you're using steam, you need to be able to accommodate the pipe and the ends of the pipe. When you have a building that's more than 3 stories, you'll be distributing the ventilation along with mechanical, electrical, and telecommunications. Uh, you can do that in the same shaft. So if we had a tall building, for example, we would run our phone cables from the basement. Let me rephrase that. If we had a tall building with a shaft, we would run our phone cable up the building shaft to supply phone lines to all the floors. We will also do the same thing with our ventilation and our electricity. We'd run all that up the same shaft and then distribute it horizontally. This really applies if your building is over 3 stories. So it's important to consider not to put a vertical shaft next to a staircase or an elevator unless 2 sides are available so that you can access ducts, pipes, and conduits. And you need to allow maximum headroom in the ceiling. Uh, it's easier to build a shaft that is a 2-to-1 or 4-to-1 rather than a square. And we'll learn more about this later, but in general, uh, a shaft that looks like this, and this is supposed to be a square, a lot more difficult than, say, a shaft that's like this, 2-to-1, or even a shaft that's like this, 4-to-1. I think this is much easier. This is much easier to build. This is a lot more difficult to build. So, in a multi-story building, uh, having the vertical distribution system with very few ducts is desirable. It's cheaper. It's easier to balance. there's less conflict with pipes, beams, lights, and since we don't have too much horizontal system, we can make our floor to floor heights much smaller. And so, you know, 100-foot tall building could have 20 floors instead of 15, because every floor can be smaller because we don't have all this wasted space between the floors where we have to fill in our HVAC equipment. And of course, we need to look at rooftop units, consider how much a rooftop unit costs to install versus how much it costs to operate. A system that's expensive now might not be very expensive to maintain, and vice versa. So here's an example of a rooftop unit. Yours might look the same, it might look different. It's important that the mechanical and electrical rooms in the building allow you to move large, heavy equipment in, out, and through the building. So that means you need a loading dock, you need a freight elevator, you need doorways that are wide and tall. And the reason is you need to bring in equipment, tools. Sometimes equipment breaks down and has to be replaced. If you can't bring new equipment in to replace what's broken down, then you're going to fail.